is essential to solving some of the greatest challenges we face in the 21st century. Here at CREOL, the College of Optics and Photonics, we're poised to meet these challenges in both our research and our educational programs. This involves you, who will ultimately find the solutions for these grand challenges. I invite you to learn more about our undergraduate bachelor's degree in photonics science and engineering.
I was in my orientation at the beginning of my freshman year when I was choosing my major. I had to look for the different engineering majors that there were, and I saw photonics. And then the word kind of piqued my interest because I was like, oh, photonics, what is that? So then I looked it up and I saw pictures of lasers, image sensors. I saw computers, screens, fiber optics, communication, defense. I saw all those things and it really piqued my interest.
century was the era of the electron. The 21st century is going to be the era of the photon. So we're at fundamental limits on where computing can go and electronics can go. And to get to that next phase of development of technology, it's all going to be powered by optics and photonics. It's truly the future.
At Duke, I'm working on an imaging technique which utilizes the fact that as light passes through a material, it slows down based on the properties of that material. So for us, in our research, the material that we look at is live cells at a single cell level. And so what's really cool is that while we image these cells, we can collect the information, do a bunch of complex mathematics in the computer, and then look at the differences between the cells and determine if this cell has the potential for cancer or if it's a healthy cell. And this is really great because we can use it for the early detection of cancer at a single cell level.
We face a critical need for photonics engineers. As the only university in the state of Florida, and with only 6 programs in the nation like ours, our graduates are finding employment quickly upon graduation. In fact, many of our students are hired months in advance of graduation. The U.S. Department of Labor forecasts that there will be about 12,000 job openings annually, and about 470 of those within the state of Florida alone. We are a fairly young program. We formed in 2013, and since that time, our graduates have been hired at companies large and small. Some are companies you will recognize who integrate photonic components into their devices and products, like cars and aircraft. Other less recognizable ones design and build core components such as sensors, fibers, and lasers. Some of our graduates opt for graduate school, and our students have been accepted into top schools such as Princeton, Duke, Stanford, and Berkeley, as well as our own college, the College of Optics and Photonics. So what do you need to do to become a photonic engineer? Our program depends heavily on a core of math, calculus, and physics. And since photonics lives at the intersection of electronics and light, our students need to have a strong understanding of electrical engineering. From there, students study the core of photonics that includes coursework in fiber optics, laser engineering, optoelectronics, imaging, and displays. This coursework opens a multitude of job opportunities.
Once I finish my senior design project, which is a project that we all have to do before we graduate, where we pretty much work with other engineering majors and we bring our skills together and make a really cool project work, I'm gonna work with the Department of the Air Force, then eventually get my master's in optical sciences and photonics, because that's the area that I like and love. And then I plan to get my PhD as well.
One of the benefits of the optics program is it's a little bit smaller. So it's a little bit more individualized, which also means there's a lot of opportunities for things if you ask. So the ability to do research. I did research as an undergraduate. It was a great way. I did stuff as in high school even, but I made holograms in my basement in high school, and now you can do that. It's much easier to do.
I believe that being successful at Creel is both readily available and possible because of the care and attention that the professors provide. This is largely due to the fact that the class sizes are smaller in our majors. So, you get this very personal time with the professors and also with your peers, where you can make these deep connections with each other and study together. And, if you have any homework questions, you can always drop by a professor's office and they're happy to talk with you about the homework or just chat about their research so that you can learn about what's going on in the field. And so, the material, yes, it can be challenging, but that's going to be true at all universities across America and beyond. So, having the fact that you have this support system at Creel that's so great between the advisors and the professors and the students themselves, you know that when the going gets tough, you have a support network and you'll be able to get through it. And I think that that's really special at Creel.
One of the questions I get asked is, it seems like this field is narrow and limited, so why would I major in photonic science and engineering? but I hope you've seen that the opportunities are vast and they will only continue to grow in the 21st century. If you'd like more information about the Photonic Science and Engineering program, check out our website at creole.ucf.edu and help create the future of optics and photonics.